Welcome to AI for Specialists. If you're an engineer listening to this, you probably feel it already. Our field, well, it's at a truly historic inflection point.
Absolutely.
The rapid spread of AI, particularly generative AI, it's arguably the biggest disruption to how we work and learn as engineers since, post-World War II?
Easily. It's a paradigm shift.
And right at the center of all this is something we're focusing on today. The AI skill gap. That's this critical and honestly widening gap between the skills industry needs right now and what many traditional engineering programs are actually teaching.
Yeah, it's a real disconnect.
And it's not just impacting niche roles, is it?
Yeah.
It's holding back innovation, productivity, even affects national competitiveness.
It absolutely does.
So our mission for this deep dive is to really unpack what this gap means for you and figure out what it takes to become an AI-ready engineer today. Okay, so let's dig into this gap. It sounds serious, but it's not just some abstract idea, right? It's got real economic weight.
Oh, definitely. It's very tangible. We're talking about a systemic issue, really. It's not just that we don't have enough programmers.
Right.
It's about failing to produce talent with these new core competencies. We see it in the data. Deloitte found, 68% of executives reporting moderate to extreme skill gaps?
Wow, that high.
Yeah. And the World Economic Forum predicts AI might displace 85 million jobs, but create 97 million new ones.
Okay, so there are jobs, but
But the catch is, up to 40% of all workers might need new skills in just the next few years. That's a huge retraining challenge.
and this is where it gets really interesting looking at the economic drivers.
Yeah.
The imperative to adapt.
Exactly. The costs and rewards are becoming stark. McKinsey showed firms using AI intensively have 2.5 times higher total shareholder return growth.
2.5 times.
Yep. And PwC noted industries heavily exposed to AI saw productivity growth nearly quadruple since just 2022.
Quadruple. That's massive.
It is. And look at demand. The UK saw a 111% jump in AI job postings between 2019 and 2020 alone. Forrester thinks we'll see nearly 15 million new AI jobs in the US over the next decade.
So the jobs are there, the productivity gains are there.
Yeah.
What about wages?
Huge pressure there. That same PwC study, they predict workers with specialized AI skills will command an average wage premium of 56% in 2025.
56%. That's
More than double the premium from the previous year. We're even hearing about big IT firms like HCL Tech offering fresh grads with niche AI skills salaries up to 4 times the standard entry-level rate.
4 times. So it's intense competition for talent.
It really is. And fundamentally, this points to a kind of structural market failure. The educational supply chain just isn't responding fast enough to these incredibly clear economic signals, hence the accelerating wage premium.
Okay, the stakes are clearly enormous, so let's pivot to the skills themselves. What defines this AI-ready engineer you mentioned? What should people listening be focusing on?
Right. It's not like there's one single mold. It's more helpful to think of it as a stack of capabilities.
As a stack, okay.
Yeah. So at the bottom, the foundation, you need AI literacy and a data-centric mindset. That means really understanding the core concepts, the data lifecycle.
The basics.
The basics, yes, but also critically ethical literacy. And I need to stress, this isn't a soft skill. It's a core technical requirement.
How so?
Being able to identify potential bias in data or models, understanding unintended consequences, that's crucial for building responsible AI.
Got it. Technical, not optional. What's next in the stack?
Then you've got advanced prompt engineering. This isn't just typing simple questions anymore.
Right, it's evolved.
It's become a sophisticated discipline for guiding these powerful generative models to do really complex, specific tasks effectively.
Okay. Foundation, prompt engineering. What else?
Next up is validation. And honestly, this might be the most critical skill right now and also the most overlooked.
Validation. Tell me more.
Enterprise-grade AI model validation isn't just checking if it works sometimes. It means rigorous testing for accuracy, yes, but also for robustness, reliability, fairness, and security.
So much more comprehensive.
Absolutely. It's fundamentally about risk management. We're moving from traditional deterministic engineering where things work predictably to dealing with inherently probabilistic systems. That's a major mindset shift.
Managing uncertainty, essentially.
Precisely. And the final layer, integration. Thinking about AI systems integration and MLOps.
MLOps, machine learning operations.
Exactly. That's the whole last mile, actually deploying these models, monitoring them in the real world, maintaining them over time, making them work reliably in practice.
That stack literacy, ethics, prompting, validation, integration. It really does sound like it transforms the job.
It does.
But connecting this back, many engineering programs let's be honest, they feel a bit stuck. Like they're preparing students for the 1990s, not today's AI-driven world.
That's often a fair critique. Now, the traditional foundations, math, physics, core engineering science, they're still absolutely essential.
You still need the fundamentals.
Of course. But the approach is often flawed. Too much focus on, say, rote calculation.
Grinding through equations.
Right. At the expense of teaching students what needs calculating, why, and crucially, how to validate the outputs, especially when AI tools are doing the heavy lifting on calculation.
And then the structure.
Often rigidly siloed, different departments barely talk, and AI, it frequently gets bolted on as maybe an upper-level elective, if you're lucky.
Not integrated throughout.
Rarely. It needs to be woven in from the start.
So if the current model isn't working, how do we fix it? How do we re-engineer engineering education itself? What's the blueprint?
I think it rests on about 3 key pillars for transformation.
Okay. Pillar 1.
A new pedagogy. We need to embrace cognitive offloading, using AI tools to automate the routine, calculation-heavy tasks. This frees up students' cognitive bandwidth for what really matters now. Higher-order thinking, complex problem-solving, creativity, design thinking, and critically, that validation piece we talked about.
So shift the focus from doing the math to evaluating the results.
Exactly. Evaluating AI outputs critically becomes a core skill.
Okay. New pedagogy. Pillar 2.
A new architecture for the curriculum itself. I like the idea of a T-shaped integrated curriculum.
E-shaped.
Yeah. Think of a broad horizontal bar representing AI and data literacy foundational knowledge for all engineering students, regardless of discipline.
So not just for the computer engineers.
No, for mechanical, civil, chemical, all of them. And this isn't just one course. It's integrated, woven throughout their studies. Then the vertical bar of the T is their specific engineering discipline specialization.
Integrated, not siloed. Makes sense. And the third pillar.
A new assessment model. We needed to move towards open tool environments for exams and projects. Assess students on their ability to use these tools effectively and, again, validate the results. Grading needs to focus on evaluating real-world competence, not just closed-book memorization or calculation speed.
So testing how they use the tools and think about the output.
Precisely. And, this whole transformation, it fundamentally changes the role of the educator, too.
How so?
Less sage on the stage, just lecturing information, and more guide on the side, helping students navigate these complex tools, ask the right questions, and develop that critical evaluation mindset.
It really sounds like a full system overhaul is needed.
It is.
And it seems obvious that the path forward needs, a concerted collaborative effort. Academia can't do this alone. Industry needs to be deeply involved.
Absolutely. Partnership is key to build that resilient, innovative engineering workforce we need.
Reflecting on this deep dive, it really strikes me that this isn't just about learning about AI as another subject.
No, it's separate.
It's about fundamentally transforming how we learn, how we teach, and how we even approach engineering challenges themselves. It's about being ready not just for the future that's coming, but actually being equipped to build it. Brick by digital brick, as you might say.
Well put.
Well, that's all the time we have today. Until next time on AI for Specialists, bye-bye.